This is going to be topic 11.3, and it's conditional probability. Bless you. All right. And so, conditional probability is when you're given two events A and B. Conditional probability is the probability of event occurring, knowing that A has already occurred. So because you know that like a certain thing has happened, it kind of eliminates part of the population. So you only look at certain part of it. So I kind of like conditional probability actually. So the notation for conditional probability, we're going to still have that P that just stands for probability. And then we'll have B. And then you have this straight bar. So when you see that straight bar, that's conditional probability. And then A. And how you read that is the probability of B given A. So we know A has already occurred. Now you want to find the probability that B is going to occur. Great. And to find that, P of B given A, we're still going to do a fraction just like we almost always do for probability. And on the numerator, it's going to be the number of ways A and B can happen. And then on the denominator, it's just going to be the number of ways A can happen. And that doesn't make a whole lot of sense right now when you're looking at it, but as we do it, I think you're going to be fine. All right, and we're not going to do number 2 on this, so you can mark out number 2 if you want to. Okay, so let's look at number 1. Mitchell drew a card from a standard deck of playing cards. What is the probability that he drew a queen given that the card was red? So we want the probability of a queen, which I'm going to call Q, given red, which I'm going to call R. Now, when I do probability, I almost always do the denominator first, like focus on the bottom first. And so this bottom of the fraction should be how many red cards are in the deck. So how many red cards are in a deck? 26 red. All right, and then now we're only looking at the red cards. So out of all of the red cards, how many of those cards are queens? How many red queens are there? 2. So there's 2 red and 2 black. So we are only caring about the red. So there's 2 red. All right, and then that will simplify down to 1/13. So it's the same idea of probability that we've been doing. You just kind of get rid of part of the cards or whatever. All right, let's look at number 3. So there are 62 people that take yoga class and 48 people that take spinning class at the gym. 15 people that take yoga also take spinning. If a person from these groups is selected at random, find the probability that he or she takes yoga class if you know they take spinning class. So we want probability of yoga, which I'm going to call Y, given spinning class. Now we're going to do a Venn diagram. Like, it might have been a really long time since you guys have done Venn diagrams. Probably middle school, but I don't know. So we're going to draw two ovals that intersect. And I'm going to call the left one yoga and the right one spinning. And I'm going to start where they intersect. So where they intersect are the number of people that take both yoga and spinning. So how many people was that? 15. So in that middle, we're going to put 15 people. All right. And then this yoga oval should contain all the people that take yoga, which is 62 people. 15 people have already been accounted for. So how am I going to figure out the rest? What would you do? Yes, 62 minus 15, which is 47 people, only take yoga. And we'll do the same thing for the spinning class. So I know there's a total of 48, but 15 people have already been counted. And so that leaves 33 people that only take spinning. Okay, so again, we want to find the probability that a randomly selected person takes yoga given that they do take spinning. So this denominator of the fraction needs to be the number of people who are in spinning class, which is 48 people are in spinning class. All right, and then we're only going to look at that 48. So out of those 48 people, how many are in yoga class? Say it again. Maybe I shouldn't have marked out everything. We're not. Yeah, there's just 15. Okay. Well, okay, so we know they're in a spinning class, so we know it's this group of people. So out of this group of people, how many of those are in yoga? No, we're not looking at the 47. All of these people take yoga. All of these people are in spinning class. We're only looking at the people in spinning class. So the people in that group that also take yoga are these 15. Okay. Right, that fraction will reduce. If you want to reduce it, it reduces to 5/16. Right. Now we're going to do a Venn diagram for number 4. Number 4 is slightly more difficult than number 3 was. Not to do the Venn diagram, but to actually answer the question. All right, so of the 30 students in Miss math class, that's important. We're going to come back to that 30 in a second. 13 are athletes and 9 are in the band. 3 of the athletes are also in band. If one student is chosen at random, find the probability that that student is in band if it is known that they are not an athlete. All right, so let's do our Venn diagram with athletes and band members. All right, what should go where they intersect? I don't think so. No. It's going to be the three people that are in both would be in the middle. All right, so there's 13 athletes. 3 are already counted, so that leaves 10. And there's 9 people that are in the band. 3 have already been counted, so that is 6. All right, so that really wasn't any different than what we did on the last one. This next part is what makes it a little more challenging. So we want the probability that a student is in the band, so I'll say B, given that they're not an athlete, so not A. right. So out of the 30 students, the whole 30 students that are in her class, how many are not athletes? Or what would you do to figure out how many are not athletes? Subtract. You're going to do 30 minus 13. So that's 17 non-athletes. Okay, so this is kind of weird, but when we're looking at this Venn diagram, we're only looking at people who are not athletes. So the people who are not athletes are these people. And all of those people are in the band. So that makes 6 people. And that won't reduce. All right, any questions? All right, the next few examples use these two-way tables, which are really kind of nice to do conditional probability. So a two-way table is a table that records data that pertains to 2 different categories. So on this example, the table shows the results of a poll of 50 randomly selected students who are asked whether they prefer to watch hockey or football. All right. And so on A, we want to find the probability that someone is chosen that prefers football given that they're a girl, that it's a girl. And so on this one, we only care about the girls. We don't care about the boys for A. Now, B, we'll talk about boys. But for A, we only care about the girls. So how many girls are there? There's 22 girls. So you would just add that column. And if we're just looking at girls, how many of them prefer football? 6. So 6 is going to go on the top. All right. Now, honestly, I'm fine with you leaving your fraction like that. On a multiple choice test or quiz, it will be reduced. But actually understanding the probability is getting that first fraction, not necessarily the second one. All right, now I'm just going to go ahead and add all the columns up. So the boys column, you add those, you're going to get 28. And then the preferred football row, when you add those, you're going to get 24. And then preferred hockey row, that's going to be 26. So when I see these tables, I usually just go ahead and do that. It saves time later whenever you need it. All right, so this time I want the probability that you select a boy given that they prefer hockey. So on this one, I only care about the hockey people. I don't care about any of the football people. So how many people is that prefer hockey? 26 people. 26 people goes in the denominator. All right. And then out of that, those hockey people, how many of them are boys? 10 of them. Right. And then, say what? It just says boy, though? Right. Well, whenever we just eliminate this, just use this row, we're only talking about the hockey people because we know it's a hockey person. This is what it tells us. It's definitely a hockey person. So that's the 26. And so we just look at the hockey people to decide the top. All right. Any other questions? Okay. We're going to do several more. It's just like this with a little bit of extra thrown in. Sometimes you'll get these two-way tables and they don't ask you a conditional probability question. They just ask you a regular probability question. So the only ones that are conditional probability questions are the ones that have this straight bar. So if we're looking at number 5, B, C, and D are what we're learning today. A is just regular old probability like we've already talked about. And so A says we're going to randomly, this table shows a poll of 150 randomly selected middle school students who were asked if they take French or if they take Spanish. And so this question, we randomly select a person. What's the probability? It's a 7th grader who takes French. This is out of all the people. So all the people is 150 people. So out of all the people, how many of them are 7th graders who take French? 25. All right, so that's not what we're doing today. That's like regular old probability. Okay, the rest of these are like what we're doing today. So I'm going to go ahead and add up all my columns and rows. So there are 82 French people and 68 Spanish and 42 6th graders. I'm just adding the columns and the rows. 37 7th graders and 71 8th graders. Okay, so B says we want the probability of selecting an 8th grader given that they take Spanish. So who do we care about? We only care about Spanish. So if it tells you, you know for sure that they take Spanish, these are the people we care about. We don't care about anybody else. And so how many of those people are there? 68 people. So I know I have a 68 in the denominator. All right, and again, we're just looking at the Spanish people. We're not looking at anything else. And we want to know out of those people, how many are 8th graders? 33. And so that's going to go in the numerator. And that doesn't reduce. All right. Let's look at C. So we want the probability of selecting someone that takes French, given that they are a 6th grader. So who do we care about? We only care, the first thing that we only care about is 6th graders. So we're going to look at all the 6th graders. And out of all the 6th graders, there are 42 of them. All right, so we're still looking at them. And then what we want now is how many of those 42 take French, and it's 19. And that doesn't reduce either.
Would B not be 71 on the bottom?
So you look at what's second. So if it's, we know they take Spanish, you look at the Spanish people.
Give us an 8th graders.
I know. That's the second thing you look at. So if you're doing the bottom, I always do the bottom first. And so it tells you to take Spanish. There's 68 people that take Spanish. Those are the people you're using. And then the 8th grader, you go to that number inside that column. So if you were doing D, do you start with how many 7th graders there are or how many French takers there are? It matters what order it's written in. French. So whatever's second, those are the only people you care about. So right now, I only care about the French takers. And there's 82 of those. All right, and then we still look inside that column of French takers, and we want to know how many of those are 7th graders. Okay, we're going to do one more. And this question is about a table that shows a poll of randomly selected juniors and seniors who were asked if they attended the prom. Now, again, conditional probability is only a situation where you have this bar. So on this one, we know we're talking about seniors. On this one, we know we're talking about people who attended the prom. On the first one, we're talking about everybody. All right, so I added up all the people who were asked this question, and that was 200 people. All right, so out of everybody, how many are juniors that did not attend the prom? 56, right? And then I'm going to go ahead and add up all my rows and columns. So there's 84 juniors, 116 seniors, 125 said yes, and 75 said no. All right, so for B, we want the probability that someone did not attend the prom given that they're a senior. So who do I care about? Seniors. I only care about seniors. There's 116 of them. All right, so if we're still just looking at the seniors, how many of them did not attend? 19. All right, you guys try C on your own, please. I think it really helps to get the denominator first by looking at what's written second. So on this one, we only care about the people who said yes. And there's 125 of those people. All right, and out of those people that said yes, we want to know how many were juniors, and that's 28. Oops. All right, what questions do you guys have?